This is Algebra 2, Unit 10, Lesson 3, Creating Polynomial Equations. Now, in the last lesson, we looked at the connection between the zeros of the polynomial and its factors. Basically, what we do is we take the factors of a polynomial, set them equal to 0, and we find the zeros. This connection can be used to create equations of polynomial using the factored form of a polynomial. So what we're going to do is we're going to start with the roots and work backwards to figure out what the equation was. So this is kind of the formal way of doing it. The factored form of a polynomial. If the set R1, 2, 3, to R of n represents the roots or zeros of a polynomial, then the polynomial can be written as this right here. So basically, this is factored form. It's factored that we could take each of these bubbles, set them equal to 0, and we could find the roots. And a is some constant determined by another point. So let's use that fact that we're going to use the factored form of a polynomial and work backwards. Okay, let's try the first exercise. Determine the equation of a quadratic function whose roots are -3 and 4, and which passes through the point 2, -50. Express your answer in standard form, y equals ax squared plus bx plus c. Verify your answer by creating a sketch of the function on the axes below. Okay, so we are going to start out with our two roots. Our two roots are x equals -3 and x equals 4. All right, now, when we write the standard form of a polynomial, it's got to be ax squared plus bx plus c, we could factor this and get bubbles. That's what we're going to do. So we have to figure out what bubbles we had here originally. So if x is equal to -3 is one of my roots, I know that this originally had to be x plus 3 is equal to 0. And this one, x equals 4, was originally x minus 4 is equal to 0. So what we're going to do is we're going to take these two bubbles and put them together with an a. So y equals a times x plus 3 times x minus 4. There's my two factored values, and I have to multiply by some a to get the standard form. Okay, now, it is determined, the a is determined by the point that we know is on the line, which would be this right here. So we have 2, -50. So to figure out what a is, we plug in x is 2 and y is -50. So -50 would go here. A was what we're looking for. Put in a 2 for all the x's. All right, so that gives me -50. A, 5, 2 minus 4 is -2. So a times 5 times -2 is -10a. All right, and then solve for a. So what's a going to equal? Divide by -10, a is going to equal 5. So now that we know as a is 5, we know these two right here, we can write the equation. Y is equal to 5 x plus 3 times x minus 4. There's factored form. But we want it to look like this, so all we have to do is multiply it out. Well, I'm going to FOIL these two. X plus 3 times x minus 4 is x squared, minus 4x plus 3x is minus x, and 3 times -4 is -12, and then multiply through by 5. 5x squared minus 5x minus 60. Okay, so I want to be able to graph this parabola. All right, we know the zeros are going to be at -3, 1, 2, 3, and +4, 1, 2, 3, 4. According to this equation, what should be my y-intercept? The y-intercept should be -60, so that'd be about there. All right, so this is a parabola. It's going to come down and go back up, and we can probably figure out the vertexes if we need to, but for our equation, let's just draw it for right now. It should look something like that. So there is my parabola. Now let's see how close we came on our graph. All right, so I'm going to put in y equals 5x squared minus 5x minus 60. And my window that is being used here is from -7 to +7, and from -100 to +100. So I'll put in my calculator to verify. And let's see how close we came. Geez, that's pretty good. Okay, so there's the -3, there's the +4, y-intercept is right here. Yeah, I've turned my Let me turn my grid lines on so I can see it. Okay. All right, and you can see when it comes down, you can find the y-intercept pretty easily, looking at x equals 0. Whoops, forgot to turn this back on. Okay. Now if I look at my table, x is equal to 0, y is at negative 60. So yeah, that is the correct graph. And we just did that by using the zeros to write the equation. All right, it's very important to understand how the a value affects the graph of the polynomial. This is easiest to explore if the polynomial remains in factored form. Because remember, the a value indicates that it's going to be some kind of stretch, a vertical stretch or a compression. So if your a value is either stretched or compressed, it's going to affect what the graph looks like. So consider the quadratic polynomials in the form y equals a times x plus 2 times x minus 5, where a does not equal 0. So what are the x-intercept of this parabola? Well, we take the bubbles and set them equal to 0. It would be x plus 2 is equal to 0, so x is equal to negative 2, and x minus 5 is equal to 0, so x is equal to 5. So our zeros are going to be at negative 2 and positive 5. 1, 2, 3, 4, 5. Okay, now this is going to be a parabola. So x plus 2 times x minus 5, when we graph it, let me go to my calculator here again. All right, we have parenthesis x plus 2, x minus 5. All right, let me set my window. And then we have from negative 5 to 9. And then from negative 50 to positive 50. Positive 50. And if I graph that, there's my parabola. You can see it comes down. My zeros are at negative 2 and positive 5. All right, so that's going to look like this. I'll even do it in blue so that you can tell which one is which. All right, so here's the blue one. It comes down like this and comes up like that. All right, so that would be the original x plus 2 times x minus 5 equals y. All right, now 2 times x plus 2 times x minus 5, it's a vertical stretch by a factor of 2. All right, we talked about vertical stretches before, so this is going to be a vertical stretch. So when you do a vertical stretch, what is affected? The x's or the y's? The y's are affected. So it's going to be a vertical stretch. It's going to narrow because the a value is greater than 1, so it's going to be narrow. So let's look at this in the calculator. I'll do 2 times this, x plus 2 times x minus 5. All right, now compared to the blue one, this red one has the same x-intercepts, or zeros, but it's going to be stretched. So if you grab the blue one and pulled, it's going to narrow up so that the red one becomes narrower, and it has a deeper y-intercept. Or, yeah. Okay, so it's going to come down like this and be narrower than the blue one. So this is y equals 2 times x plus 2 times x minus 5. All right, so 4 is going to stretch even more. X plus 2 times x minus 5, so that should be even narrower. Let's see if it is. All right, so I'll do that third one in black. This is 4 times x plus 2 times x minus 5. So that's going to stretch even more, and you can see it comes down even farther, but the x-intercepts stay the same every single time, because when you do a vertical stretch, it only affects the y-coordinate, not the x-coordinate. Okay, so your third graph looks like this. It's going to be even narrower. It's going to fall down even farther. Whoops. When we go down like this, oops, that's kind of off there. It's going to go down and then come up like this. There we go. All right, so that gets even narrower. 4 times x plus 2 times x minus 5. So the a value is going to make it a vertical stretch, so it's not going to affect the intercepts, x-intercepts, but it is going to affect the y's. All right, so as we just said, the value of a does not change the zeros of the function, but does vertically stretch the function. We can create equations of higher powered polynomials in a similar fashion. So keeping the same idea of that, it's going to be a times the factored form of the polynomial using the zeros. So let's create the equation of the cubic. So this is going to be an x cubed in standard form. So x cubed, x squared, x, and so on and so forth. And it has x-intercepts of -4, 2, and 5. And it's going to pass through the point 620. All right, so let's see if we can come up with an equation for this. All right, so if we know that x equals -4, x is equal to 2, and x is equal to 5 were the original, or are the roots. What was the bubbles that gave them that? Well, if x equals -4, this was x plus 4 is equal to 0. This one was x minus 2 is equal to 0. And this one was x minus 5 is equal to 0. So our three bubbles that we're going to have here, if I set this up in y equals a times the factored form, x plus 4, x minus 2, x minus 5. Okay, so that's the general form. Now all I need to know is what a is. Well, all we have is that it passes through the point 620. So x is 6 and y is 20. So I plug in 20 and I solve for a. 6 plus 4, 6 minus 2, 6 minus 5. So 6 plus 4 is 10, 6 minus 2 is 4, 6 minus 5 is 1. So this is going to be 20 is equal to 40a. And then divide by 40, excuse me. So a is going to equal 1/2. So in factored form, if I rewrite this equation, I put in 1/2 for a, x plus 4 times x minus 2 times x minus 5. But this says to be in standard form, so we want this in highest exponent first descending order. So we've got to multiply all these together. All right, I'm going to multiply these two first, and then I'll multiply the x plus 4. All right, so this is going to be x squared minus 5 minus 2 is minus 7x, and then plus 10. Then I have to multiply this times this, so that's going to be a very large polynomial. All right, let me do it off to the side over here. So x times x squared is x cubed, x times minus 7x is minus 7x squared, x times 10 is 10x, and then I'm going to do the 4. 4 times x squared is 4x squared. I lifted underneath the x squared. 4 times -7 is -28x, and then 4 times 10 is 40. So combine my terms. That gives me x cubed, minus 7 and 4 is minus 3x squared, 10 and -28 is minus 18x, and then plus 40, or minus, yeah, okay. And then I want to multiply the half through the parentheses. So this is going to be 1/2 x cubed, minus 3/2 x squared, minus 9x, and then plus 20. So that should be my equation. All right, so let's see what it's going to look like. The zeros, -4, 1, 2, 3, 4. X equals 2. X equals 5. 1, 2, 3, 4, 5. All right, now if I go to my calculator and put it in, y equals 1/2 x squared minus 3/2, or x cubed, I'm sorry. X cubed, not x squared. Minus 3/2 x squared minus 9x plus 20 with a correct window from -5 to 7 and from -100 to +100. -100 to +100, and graph it. There we go, and I have the correct zeros. All right, so it should look something like that. Okay, looks a little neater on the paper, but you get the idea. Okay, so that is using the factored form to get the polynomial. Let's save exercise 4 for the next class.